Hello friends, MoNaCo here, our third lecture in our units on solutions. We're talking about table G and saturated versus unsaturated solutions in this series here. Table G is a very useful reference and we have to learn how to use it properly. So there's a lot of practice revolving around this. So the lead-in is, how can we predict how much of something will be able to dissolve into solution? Like, how much salt will dissolve into this cup of water that I have? Well, we're going to use the solubility graph to help us understand saturated, unsaturated, or supersaturated. And that is the focus of this lecture. So the different types of solutions, there's really only 2 to 3 types. Unsaturated solution is when you can put more solute, more stuff, more solid or gas can dissolve into the solvent. A saturated solution is you got the maximum amount in there. It's full, okay? Now, a saturated solution is what we call at equilibrium. Equilibrium is where we've got the crystals that are dissolving are also equal to the number of crystals that are solidifying in that beaker. It's a little situation that happens. So here we have a couple images, although poorly photocopied, of a situation where we have an unsaturated solution. So if I add some salt, sodium chloride, to water, and nothing is left over at the end, all that salt's dissolved up in here and there's no particles, that's unsaturated. I could put more in. A saturated situation is where I put more salt in and some ends up sitting down at the bottom, not dissolving. That little bit left over tells you that all the salt that could dissolve has dissolved, and now the leftover is sitting at the bottom. This is at equilibrium. It's balanced. The amount of dissolving is balanced with the amount of crystallization. So let's move on here. The third type of solution is a supersaturated solution. It contains more solute, more stuff, than it would normally dissolve in a given volume. This usually requires the chemist or the person to do something special, like increase the temperature of the liquid or increase the pressure on it initially. This is very unstable. I can't really show you one of these unless my system works properly this time. I'm going to try to show you a supersaturated solution, but I can't guarantee it as a demo because I've never been able to make it work because they're so unstable. So 3 types of solutions: saturated, unsaturated, and supersaturated. Situation: if you've got an unsaturated solution and you add more, what would you see? If I have an unsaturated solution, I add more crystals, you would see that they would dissolve or disappear. It's like adding more sugar to your coffee. It will dissolve and you can then taste it in your coffee. The rate of dissolving is greater than the rate of precipitation. Precipitation in chemistry means becoming solid. Okay, precipitation in chemistry is different than precipitation in earth science. So if you have a supersaturated solution and you add more crystals, what would you see? Well, it's already holding more than it's supposed to, and you add more crystals, all of a sudden, all of them are going to fall out and crash out. It's kind of like the Jenga tower. Like you add more Jenga blocks to the top, it becomes super unstable, and all the crystals that were not supposed to be dissolved, but you tricked, will come crashing out. In this case, the rate of dissolving is less than the rate of precipitation. So very few crystals dissolve, while many, many, many precipitate out. Now, if you have a saturated solution and you add crystals, what would you think you see? If the solution is already holding the maximum amount, what could you see? Well, you would see the crystals that you just added sink to the bottom and kind of do nothing because the rate of dissolving is equal to the rate of precipitation. So for every crystal that dissolves becomes aqueous, you've got an aqueous crystal that's crystallizing and becoming solid. So we have this kind of situation where it's an equilibrium. So that's what we call equilibrium. Rates of dissolving are equal to the rates of crystallization. So let's get to table G. This is the reference table we got to spend a lot of practice working with because it is scary looking at first, but it's actually pretty simple. Let's get to the interpretations of it. Table G shows the number of grams of a substance that can be dissolved in 100 grams of water. So table G is only good for water at temperatures between 1 and 100 degrees. Each curve represents the maximum amount of a substance, they're labeled with their chemical compound symbols, that can be dissolved at a given temperature. All lines show an increase are solids. The lines that show a decrease are gases. So we've got a slope up it's a solid, normally dissolved in the water. And if you have a slope down, it would be a gas dissolved in water. Okay, so that's just kind of like general. If the intersections of grams of solute versus temperature fall, so these are the three conditions that you're going to be looking at your graphs for when we're doing all our practice. So the intersection means when you go across from the mass and down to the temperature, and the line curve is being played. So let's just draw a little side note here. We've got, there's your heating curve, or I'm sorry, your solubility curve. Here's the line that represents the stuff that you're looking at. We're going to have three different situations. Either your dot's going to fall above the line, on the line, or below the line. And I'm talking about intersection of these types of things. So we're looking temperature and mass conditions. We're looking to see where those graph lines fall. So if you fall on the curve, that's this line right here, you are going to be talking about a saturated solution. If you fall under the curve, this one right there, the solution is unsaturated. I mean, you could put more solid in. Now, if you fall above the curve there, you are in a situation where you've got a super saturated solution, very unstable. So we're going to practice that when we are doing our practice pack a whole bunch. So this is a very important thing that a skill you got to work hard at. So using table G, we'll answer a few questions. There's our table G, copied over for us. And these are the type of questions you're going to see in your practice. How many grams of NaCl will dissolve in 100 grams of water at 90 degrees? First thing you got to do, find the curve we're talking about, NaCl. There it is. So we're talking about this line right there. You can ignore all the others. Dissolve in 100 grams of water at 90 degrees. So how many will dissolve? So we're talking about 90 degrees and 100 grams of water. So we're cool there. So let's read up from 90 degrees till we hit the NaCl line and read over to see that it says 40 grams of solute per 100 grams of H2O. So how many grams will dissolve? 40 grams will dissolve, because that's the maximum amount that can dissolve at 90 degrees, because we hit the line that shows a saturated solution and we read over to the left. That's how this graph tends to work. How many grams of KCl will dissolve in 50 grams of H2O at 30 degrees Celsius? This one's got a twist for us, but it starts in the same way. We're talking about KCl, so we find the KCl curve that we're interested in. So there's KCl, it points to this line, so we're talking about this curve right there, so we could ignore everything else on the graph for this particular problem. How many is going to dissolve in 50 grams of H2O at 30 degrees? Now 50 grams of H2O does not match 100 grams, so whatever number we got to double it so it matches the 100 grams, or half it so it matches 100 grams. So how many grams KCl dissolve in 50 grams of H2O at 30? So let's find our 30. 30 degrees. We read up till we hit the KCl line. We read over and we say that's about 35 grams per 100 grams of H2O. So if it's 35 grams per 100, oopsies, 100 grams H2O, that's got to equal, cut it in half to get 50. I think that's about 17.5 grams in 50 grams H2O. Okay, so you saw how I had to cut my number in half there because the amount of my solvent was half of what the chart is talking about. In this case, you got 200 grams, so we're going to have to double our answer, and we're still talking about KCl. So, and we're still talking about 30 degrees. So if we look up at 30 degrees up here, still 35 grams will dissolve in 100. So 35 grams per 100. So that equals, I'm talking about 200 grams, we got to double that. So that's 70 grams per 200 grams H2O. And again, we're talking about how much solid will dissolve in how much liquid. Name two substances that are solids. Well, all of the solids on this graph slope upwards. So there's many, many options. You have to pick two. So pick two substances that slope upward, have a positive slope, and write them down for this particular answer. So that's on you. You do. into substances on table G that are gases. So gases slope down. Find two substances, there's I think 3 or 4 to choose from, that slope down and write their chemical formulas. 6 and 7, let's see, is a solution that is made up of 100 grams of water and 70 grams of KNO3 at 50, saturated, unsaturated, or supersaturated. So we have to pick one of these three, depending on where our intersection is, and then say why. And the why will be because it's above, on, or below the line. So we're talking about KNO3, let's find that, and 50 degrees Celsius. And we got 100 grams of water, so we don't have to do any math here. So KNO3, there it is. Got that right there. This big line, very steep, very dramatic curve there, that one is. And 50 degrees Celsius, so we find our temperature, read up till we hit the line, and read over. And now it says, is a solution that's made of 100 grams of H2O and 70 grams of KNO3 at 50, saturated, unsaturated, supersaturated. So at 50 degrees, we can hold a total of 85 or so, but this only has 70. So the intersection that we're interested in is below the line. So we are unsaturated. Why? Because intersection is below the line. So we're kind of playing battleship and comparing on, above, or below the line to see saturated, unsaturated, or supersaturated. For 7 and 8, you're going to ask yourself how much is going to fall down to the bottom. Well, for 7, you're asking how much material falls to the bottom if we got 100 water, 100 KNO3, and 40 degrees. So we're still talking about KNO3, but this time we're only talking about 40 degrees. Okay, so let's just erase this and start there. Okay, so we got 40 degrees. At 40 degrees, 65 could fit in there, but we got 100. So if we really have 100, that's right here, this intersection's right there. So that's what we've got. So we've got 100 in there, but only 35 is going to fit. So, oh, I'm sorry, only 65 is going to fit. So you got to do like 100 minus 65 equals 35 grams. I was doing that math in my head. That's how much would fall to the bottom because it can't dissolve. It won't fit. And table G, which one is more concentrated, point A or point B? A has got more solute in it than point B, so it is more concentrated. Okay, A and Y, you explain. So the only way to get this is to practice, practice, practice. And there is 3 pages on our practice pack. A quiz online for prep. Do the prep first and then do the quiz. And also make sure that you are checking off your list. You have now finished lecture 3. You can do your practice pack. We'll have a lab on this material, and you got a quiz there to do as well. So thanks for watching. Enjoy.